cameras here today. So, hey guys! Whoa, I had a rough time getting ready because I had a nice fresh glass of iced tea here, and well, I now have a desk mat infused with iced tea. So that wasn't great, and I think my camera's crooked. There we go. And welcome. Yeah. Oh, I'm in the chat. Well, I guess it's because of this different angle. Oh, no other way around. There we go. That should fix it. Let's refocus. Huh. Modern technology. Anyways, welcome to the stream. Today we're going to start building this this little prototype board I have made, and well, let's see for how long we go and how far we get. But let's see who's all here. Oh, Draadstaal was, I think, the first one to comment, and then Philip is here, one of my moderators on the Discord. That's cool. 9 p.m. here. Okay. Yeah, music. I like having music in the background, but I should turn it down. There we go. There we go. Let's see here. MSX Droid is here. Nice. Iratarto says, come out, Quindor. Magic smoke time, says Ockert Marias. Well, there will be smoke, but mostly soldering smoke, I hope. And I'm not sure if there's going to be any other magic smoke. Well, we'll have to see about that. Pull up the curtain and show yourself, Quindor. Well, here I am. Oh, Philip says music might be just a little bit too loud. Well, we fixed that. Iced tea and electronics is magic smoke. Yeah, and I had everything prepared on my desk. So I had a power supply here. I had all kinds of wiring, LED strip, and it just fell over everything and on the floor, and my whole desk mat is wet. And well, we have replacement stuff, so that's fine. I tried to clean it up. I'm all sweaty now. But hey, we're going to make this work, or not. We'll see. It's a live stream. Anything can happen. Yako says, I just replaced the borked MOSFETs on my Anna Quin quads, so the analog boards, and now it just works. Yeah, the Chinese haven't been too great in sending out, or the Aliexpress people, in sending out correctly functioning MOSFETs, sadly enough. So if you're building the analog boards like we're doing today, this one has 5 MOSFETs too. We're actually going to be using the same ones. I think, well, maybe we'll use different ones. I'm not sure yet. But yeah, they don't adhere to the specifications very well. And then most often the trigger voltage isn't correct, so they don't work as designed. And then if you get the MOSFET from your local country, suddenly everything works perfectly. So, hey, that kind of sucks, but yeah. I think I already changed the seller from when he bought them. So hopefully the new seller sends out the right ones. Oh, Rolling Roller is here. Nice. Hey, Discord people. Next time, start the stream before you bring the tea. Yeah, and that wouldn't have been fun. I would have had to have like a be right back screen. Took me like 10 minutes to clean it all up. Your live streams are always awesome. The more smoke, the better. Well, if the result is smoke, that is the result. That's a live stream. I bought 50 MOSFETs, so you'd better use the same ones. Well, this isn't the first time I'm building this prototype, because I have one completed already over here, and that one is using those exact same MOSFETs. So don't worry too much there. I guess you can. Well, I guess I should show it on the camera here. How many people are here? 64. Well, it's not 15 yet, so I'm not going to talk about the board yet. I'll do that once it's at least a 9:15 over here. So this is the board we're building. As I said, I already built one up. And yeah, as I said, we're not going to talk about it. We'll talk about it in a few minutes. Give people time to come in. Did I miss pouring the iced tea over the desk? Yes, you did. But I have backup for everything that is now wet, and I threw it kind of on the ground over here. We're not gonna we're not gonna use that stuff. I even have a backup drink, and this time it's Coca-Cola Zero Cherry. Yes, fancy drinks. What are you guys drinking? Do you guys have a drink? I'd get a drink. This is probably gonna be a long stream. Wait, do you buy your MOSFETs on Aliexpress and such, or on LCSC, Mouser, Farnell, etc.? I actually use a mix of all of those. I like using Aliexpress for most of the stuff because it's generally just the cheapest, and especially if I don't mind how long it takes to come in, I'll buy it from Aliexpress. My second shop of choice is LCSC, but then I pay at least 20 to 30 bucks for shipping alone. So that generally has to be a bigger order, or I need to have it quickly, or I need to be 100% sure I get the original item, like for the MOSFETs, stuff like that. So, and I have bought from Mouser and DigiKey and stuff like that before too, but it's generally AliExpress and otherwise LCSC. But LCSC really effed up their website this week. I don't know, they're upgrading their website. Well, it's unusable now, so good job there. Oh, Andy has a beer. Patrick has Dr. Pepper. Nice. Can there be anything else? I don't know. I like when I was still allowed to drink sugar. I like Dr. Pepper. So, oh, nice. Joey is drinking some Grols. Monster. Oh well, Jaguar is going to be awake for a while. I bought the replacement from Eris online. Yeah, that's a fine shop too, Jaco. Not allowed sugar, but allergic to fake sugar. I'm kind of in the same deal. I'm allergic to some fake sugar, but not others, and it's also a combination thing. And I'm diabetic, so sugar is out, and I kind of have to watch the replacement stuff. But luckily what they use in Coke, I'm not bothered by. So, hey. Berenburg with some cola. Hey, that's a good thing. More Grols. Okay. 4 or 5 more hours before I can crack a beer. Yeah, you mentioned you were still at work, Phil. Well, who knows? Maybe we'll do a bit loony, and the stream will last 4 or 5 hours. I hope not. But we'll see about how long I have energy. We'll see. We'll see. Sugar. Why not use brown sugar? It's still sugar? Will there ever be more analog dimmers? I need, please. That is exactly what we're building today. So, so I'd stick around and see. Well, I already know it works, but yeah, this is a prototype. I have already made changes on the PCB design and stuff like that, but there are some tests I want to run with 2 boards. Sorry about that. I just ate. But there are some tests I want to run with 2 boards. So I was thinking like, well, I can prepare a video for this week, or we can just solder that second board together. I guess it's less exciting because I know most of the design works. There's some stuff I want to adjust and stuff like that, but you know, it's fun hanging out. It's 15 past 45 minutes till I crack a beer. Okay. Oh, Johnny's here. Hey, Johnny. Okay. So the board. Let's take a look at the board. Let's see. I prepared my my ultra zooming powers. No, don't do that. Oh well, I guess. So this is the PCB, but we'll be looking a lot at that later on. This is the board, and because I zoomed in, it got a little bit more dark. But we can just throw on more LED power. Okay, still need to focus. There we go. So, this board will be a 5-channel analog dimmer board based on the ESP32. And actually, it's based on my custom QuinLED ESP32. So you can use it with a normal board antenna, or you can use it with Ethernet, and the board is fully prepared to be able to accept Ethernet and run it like that. So, for instance, if we look at this board, we can just plug in the Ethernet, and you can put the Ethernet key cable here, and that all works. So you can run them with my 3 variants of my ESP32 boards. Now, feature-wise, as I said, we're going to have 5 high-power MOSFETs, and it should be capable of doing at least 8 amps per channel. And that is a lot for analog LEDs, if I'm honest. The design goal is basically to be able to take a LRS350-24, so that's a 350 watt 24 volt power supply from Meanwell, for instance, and that is about 15 amps, and be able to run that through the board without it heating up too much. Now, there's some notable changes versus my other analog boards, and this board will be available DIY and pre-assembled in the end, but it's going to be advanced DIY, as I call it, because you will not be able to build this using a soldering iron. I guess most of the stuff you still could, but I'd really recommend at least a hot gun. But in this case, we're going to be using this guy. Where is my mouse? There we go. We're going to be using this guy, and this is a little 10 centimeter by 10 centimeter hot plate, where you just put the PCB on, it heats up, and everything reflows automatically in the paste. So yeah, well, you'll see more about that later once we have placed all the components. But more features of the board. It has onboard regulators for 3.3 volts, 12 volts, and 5 volts. So that, well, I need all those voltages for, well, I need 5 volt for the ESP, I need 3.3 volt for accessories and the 3 dedicated button pins, and those 3 dedicated button pins also have their own hardware debouncing network, so that even if you run them with longer cables and there's a bit of interference and stuff like that, you can still connect 3 buttons and they should work perfectly. There's I2C on the board for a temperature sensor, and it's on here, but it's that little thingy over there. It's probably a bit hard to see, but we'll see that during soldering. There's I2C is broken out. This header is using SPI, and the reason for that is I don't have one here right now. I think I have one here. There we go. The idea, and I've already had this working in a test setup. It needs some changes, but it'll work in the end. Is that you can plug in one of these screens and have a little status screen, and then we also have the ESP on there. There we go. So this is basically its final form, I guess you could say, of a 5-channel analog dimmer. It has 5 volt and 3.3 volt and ground outputs for if you want to connect extra I2C stuff, because that's broken out. And then there are some GPIO pins, but the GPIO pins are pretty limited depending on the options you use. For instance, if you use the OLED screen, that takes up 5 GPIO pins that you can then not use for something else. Or if you also add on Ethernet, and currently having problems with Ethernet and the screen at the same time, but working on that. But the Ethernet takes up 10 GPIO pins, so that leaves you with very little. You still get the button pins, which you can then use in ESP Home or in Home Assistant or both or whatever, and 5 output channels and stuff like that. But it all seems pretty simple, but it's it's a little bit more complicated of a design, because one of the issues we just talked about with Jacco and his MOSFETs is that the other designs, to keep them DIY friendly and simple, they were triggering the MOSFETs with 3.3 volts. This one triggers the MOSFET gates with 12 volt and uses specialized, and you can see it over here, that little guy here, or this little guy over here, with specialized MOSFET gate drivers, which basically slam open the gate at 12 volt instead of 3.3 volt, which in turn makes sure that the MOSFET stays a lot cooler and can handle a lot more amps and switches quicker and stuff like that. Oh, and of course we have 2 fuse sockets. So we can have 2 fuses. So especially if you're running multiple white strips, for instance, you could divide those over fuse 1 and fuse 2, and then size the fuse to whatever you have connected to those channels, because there's 4 positive outputs over here. And as you can actually see on the board, there's F1 and F1 and F2 and F2. So that's fuse 1 and fuse 2, and you can divide the positive channels over those fuses. Yeah, so that's a lot more intricate or complex of a design than my current analog boards, but this is basically the ultimate ESP32 Home Assistant, ESP Home-based analog dimmer that I was able to make with onboard temperature sensors, I2C, an OLED screen, the Ethernet option, all of that included. It should be able to take up to 36 to 40 volts in. So it's also, well, it's very suited for 24 volt LED strips, but you could even use them with like 36 volts and stuff like that if you wanted to. And yeah, just the high power handling and the ultimate analog dimmer board. So I didn't look at chat for all that time, so I'm going to see what you guys wrote. Greetings from Friesland. Oh, nice. When you store components, do you keep them separated by supplier in a case? With one batch? No, I generally throw them together, but maybe in separate baggies, I guess. Let's see. Diabetic 2. Okay. With the NFC sensor on the arm. I used to do that, but currently I can manage without it. But yeah. Hey Quindo, ordered 2 Quin ASPs with and without external antennas. Still in shipping. Okay, sure. So let's see what you guys thought of the board. Price of that tool. You mean this this little soldering thingy? I believe it's about 35 bucks. I can look up a link in a minute. Yeah, oh, Andy says about 40 bucks. Yep. Affiliate links up and running. Yeah. Let me, oh, that doesn't work. Wait, yeah. Let me get that real quick. Let me get you guys a link. Because I do like that little tool. It's worked really well for me. I've been doing boards using that by now, and yeah, I like it. So, link time. Get a link. Yep, there we go. And here we go. So that's a link for that soldering platform. But we'll be using that in a few hours, so you can check that out, or yeah. Oh, Andy already provided the generic link. That's good too. Thank you. Sorry, just reading the comments here. Have you thought about putting USB-C alongside your power inputs? But the USB-C is on the ESP32 board. Why would you need to access the USB-C? I guess you could, if you didn't have the OLED screen on there, you could access the USB-C port, but for what reason would you ever need to access it? Basically, you just flash it once, or maybe if I can do it for instance for the pre-assembled, I can use Improv. You flash it once and then just put it on the board, and from that point on you use OTA. So I'm not sure what you want with the USB-C port, but no 48 volts. I've seen a few LED strip starts popping up. I looked into doing 48 volts, but maybe I can do it on the pre-assembled, because then I can build the DC buck regulator circuit myself. But currently I'm relying on off-the-shelf modules, because, well, for DIY I can't ask you to solder 04, 02, and 06, 03 and stuff like that, in my opinion. So it's really hard to get a buck regulator that'll do that for a decent price. So yeah. Yes, yes. Hello. That Quindor guy, who's that? It's me. What's your profession? I'm an IT professional. Although I've kind of started working less and doing more YouTube and electronics design and stuff like that, but yeah. PoE, will the board support PoE? It'll support PoE exactly the same as all my other boards. Oh, a way to measure the power being used by the board. I guess that could be possible, but that entails more than just a shunt. Then you have to have impedance control over your PCBs and all kinds of other stuff you need to take into account before you can do that. That's going to run up a lot of costs, and I know it's fun to watch, but I don't think it's really worth it per se. So, yeah. Yeah, so this is the new analog board. This is the second version of it. Here we can take a look at the first version I had, actually. I still have it lying around. So as you can see, the design is still somewhat the same, but some stuff has changed. For instance, I added a capacitor here because I wanted to do some testing with the capacitor. There's much more silk screen going on. The fuse holders are still there. But some other stuff did change, and internally the board is completely different, if I'm honest. It's now a 4-layer board instead of a 2-layer board, and I know that's more costly to make, but I just can't include all the features without making it 4-layer, and also having the power handling. It's either 2-layer, not handle a lot of power, or drop a lot of features, or 4-layer, and it can do all of those things. So, yeah. Okay. So, this is the PCB we're going to be building. Let me take a quick look at chat, and then I am going to start the building. Yes, Edward, LED strips are directional. That is certainly true. QuinLED-Deca is legacy now. No, I wouldn't call it that. I might rename the board in the future to An-Penta or An Quad and An Deca and then An-Penta. Or maybe An-Penta. I don't know. I'm not sure yet if I want to call it like Pro or Plus or whatever to show that it's a lot different DIY than my other boards. Arjen says, is the tool channel on Discord already up and running? It is. So, got you there. I have not fitted the house number yet. I thought about making that the video for this week, but I'm thinking it might be that for next week or the week after that. I'm not sure. Or maybe I'll do a video in between. We'll see. So, because this is going to take quite a while, I think we should get started. And I first need to get out this stuff. So you're going to be needing tweezers, because, this kind of build will be impossible without tweezers. I did try to use 0805 where possible, so all resistors and capacitors are 0805, so those would even be doable by hand, or hand soldering basically. But especially these little footprints here, and some others like like this guy, yeah, that's just not going to be doable by hand. And even with hot air, that can be done, but it's more difficult. And especially also if you want to support the higher amperages, you'll want to have a proper solder job of the MOSFET to the board. So Philip says, let's start the soldering already. But Philip, we're first going to take at least an hour placing components, so it's going to take a while. I do want to share something on the screen for that, because this will probably be the way I'm going to share this project in the future. Oh god, I need to add a new capture source. Oh, let's see. Let's hope the stream doesn't crash. Yeah, let's hope. I think I need to do this. Okay. Yes. Now, where do I put it? That's a good question. Nope. Still nope. I guess I'll have to make it really small and the text really big. See if I can do that. No, don't do that. Is that still readable? I guess it is. Yeah, I don't like hiding the chat on the screen, if I'm honest. Oh, wait, Johnny Bergdahl also stop talking and start soldering. Also, SEKS rules for sure. I don't know. I'm just gonna put it up here because then I can hide the address bar too, and I can hide this part. This will work. Okay, so I have prepared my little box of stuff here, but the first thing we're going to do is we're going to solder paste the PCB. So to solder something like this, you need something called a stencil. And a stencil is basically a piece of metal where they've laser cut all the holes that are on the PCB into a piece of metal, and you basically paste through those holes onto the PCB. So I'm gonna get a fresh PCB because then it won't have all kinds of finger grease over it. Let's get my my board out. There we go. Let's focus that. Okay. And so we need to get the stencil and see how we're going to orient it, because the board is rectangular, so we can't just go normal. Okay, I need to undo this because I want to clamp the stencil in between some other PCBs which have the same height. Luckily, most PCBs are 1.6 millimeter thick, no matter if they're 2-layer or 4-layer. As I said, currently this board is 4-layer. Almost at the 2.0. Well, this is actually an IKEA butcher's block that I use. But yeah, basically you want to get the PCB and you want to clamp it in there. And I use these little tapes to then hold it there. As I said, I think you can still do this by hand, most of it, but I really wouldn't recommend it. So then you take the stencil and you basically line it up with the pads on the PCB. And I need to hang over it for a little bit, sorry. Okay, so we take that down, so then the stencil can lay flat because the surrounding area is also flat, and we can still flip it open and flip it back if we want to do more than one board. Well, we're doing one board today, so. Andrew Maki Juski says, just because of the stuff you do for us. Thanks, man. That's awesome. Thank you very much. Okay, then we need a little thingy. And, well, I used to have a parking card in Rotterdam. I don't have a parking spot there anymore. So we're going to use that to spread the paste. And then we're going to get my little box. I have a little box called Paste and Flux. Oh, you can see it here. There we go. So let's get the paste. And I'm using expensive paste because, you know, I've got expensive taste now. This is a chip quick paste, and it's certainly not the cheapest. It's the TS39 1LT, and I'm using this version because it's 138 degree paste. Especially when you're prototyping and sometimes you want to change stuff or resolder something or replace it or stuff like that, using lower temperature. I'm not sure you guys can still hear me okay. Can you guys still hear me okay? I'll move my microphone a little bit. There we go. Especially if you want to desolder it again, using low temperature solder paste means it gets, well, loose earlier, so you don't burn up all the plastic or other stuff in your board. So, what I do, there we go, I just squirt on some solder paste. Something like that should be enough. Oh, you sound fine. Okay. Sound is good. Yeah, so for a lot of people, this will be a new way of building stuff, but in my opinion, once you're used to it, it's actually better than through-hole soldering, but we'll see. We'll see. And so we made sure this is flat, so what we can now do is we can take our paste and we can just squish it. Okay, I didn't do a good job here. Squish it through all the holes, and then we check if the paste actually went through all the holes, also the tiny ones, but that's looking good, as you can see from the top-down view. And what we can then do, we flip it back over, and I need to clean this off real quick. Where did I leave that? I always use too much paste. I don't know. So let's clean that off before we do anything else. Okay, we don't need this anymore. Yeah, that looks decent enough. It's a bit squished, but it'll be fine. It'll be okay. So now we don't need this contraption anymore, so I'm just going to clean off the stencil real quick. Hey, Christos is here. What are we building? We're building a prototype for a 5-channel analog dimmer that is suited for most people, I think, still to build DIY. So I tried to use the minimal amount of small or tiny footprints and components and stuff like that. So I kept to 0805, and there's some components which are slightly smaller, but I'm calling it advanced DIY because otherwise there's just too much restrictions on what I can design. Okay, we don't need this anymore, but are we going to use it still? I don't know. Let's see how it looks on camera. I'm going to turn it around. I don't know if there's always an orientation which I think is most logical. Not sure if it's really logical, but yeah. Okay, let's zoom in. Let's go maximum zoom. Not like that. And let's see where it needs to be. There we go. The shaking will stop in a minute. Sorry about that. Yeah, I guess there's all kind of stuff in the way now. Yeah, we need more screen real estate. That's it. Can we dual screen? Dual screen streaming. Can somebody bring out a platform where we can stream with 2 screens? I guess I could just start a second stream. We're going to try that in the future. That's the idea. We're going to do that in the future. We're going to do a dual live stream where I share 2 screens, but they're the same live stream. But then I need 2 channels, don't I? Do I? I don't know. Anyway, that's a nice idea for the future. Cool. Would it be a party foul to resell Quin boards on eBay or Amazon? Yes, it would be. There is a article on my website about that, and I'll link it real quick. There we go. Music on one and voice on the other, so people can pick their own mix. That's even better, Patrick. Nice. QuinLED's trash channel. Yeah. So there are rules for commercial use, and I consider making more than what you need personally, or maybe for your friends and such, commercial. If you're building them to sell them, that's commercial use. But check out that article. And you can always talk to me and see if we can work something out, but yeah. Especially if I'm going to make pre-assembled versions of them. Let's not. Some space channels have multiple live streams. Oh, that's true. But on the same channel, or are they different channels, Jacco? Okay, so I'm using my my tweezers again. These are titanium tweezers, and I really like them because this isn't really in focus, is it? I guess it is. Okay. Because the tip is really, really small. So this is all 0805, but especially if you're doing 0402, the smaller tip really helps. So it's definitely about size. Okay, if we look here in this document, and let me make it bigger for just a minute. So this is a document I've been working on. I can generate this document. And you can actually click on the component on the board if you want to see what component it is. So here, for instance, these are FDD8447L, these positions, and yeah, they go on those places on the board. But if I want to, for instance, oh, I'm missing this resistor. Which resistor is this? Okay, so this is R20, 0805 3K, and well, I know they're 0805 already because that's in my description. So this way you can very easily find what component you need to place where. So I'm thinking about using this instead of my soldering videos. I might still do a soldering video, but before I used to generate all kinds of screenshots and highlight all the components and stuff like that. But doing it this way, for instance, okay, what are these? Oh, okay, we have several of these, and those are MCP 1416s, and we need 5 of those, and those go on these places on the board. That's just nuts. This is called the Interactive BOM, Interactive HTML BOM. It's awesome. Anyway, let me make that smaller again. But still visible. And I have it ordered so that it does capacitors first, and then I believe resistors, and then the rest of the components. The first one is this radial capacitor, but we're gonna not solder that on for now because I mainly have that in there for testing, not so much for usage right now. So the first one is we need 0805 16 volts, or at least 16 volts. Let me kind of hesitant with my drink right now. So we need 0805 16 volts, 1 UF, and I have these. I think I've shown these before. I used these during my prototyping. They're fully 3D printed. And they have several values inside of them. And so we need 100 NF. So I can just take that out. They clip in here. And then I can take out the amount that I need, basically. So, yeah. Oh, the tape has gone in. I'm not sure why. But, okay. So the tape comes out of here. And you can take out the amount you need and then just place it back again. I'm just going to keep them in here for now, because generally... No, I'll take it out. Okay, whatever. So, how many do I need? I need 8. Okay. Oh, no. Okay. See, this is the things that never happen during... when you do this yourself, but they do when you're live streaming. The tape came out. Oh, I'll fix that later. That's fine. Okay, 8 of these. Okay. God damn it. Okay. Oh, swearing on the stream now. Okay, I think I have them. No ice tea poured over these, that's right. But, so now I can just see on the screen and I'm like, okay, I need to place one here. And I need to place one here. And one over here. And then there is one over there. Yeah, so the rest of the stream is going to be very boring because I'm just going to be placing components. But that's why we have music. Okay, last one, I think. No, there's supposed to be one more. I didn't get enough. Just put the stream on 2x speed. Yeah. Well, if you're rewatching this, I wouldn't blame you. Okay, so now I have my 0805s done, so I'm gonna tick it that I know that I've placed them all. And the next ones are 1 UF. And I need 5 of those. And I'm going to do this differently. Because I'm just going to cut it off. Okay. Oh, I've never rearranged it before, so I wouldn't know if it forgets what you've already done and what not, but... I just generally leave it on here until I'm done, basically. Okay. Now, as I said, I've already been messing with this design, changing and improving some stuff. They're mostly minor changes, so the general idea is still the same, but yeah. Let's see, these were 5. I think I got that 1, 2, 3, 4, 5. Yep, okay. If you guys see me making a mistake, do warn me. Let's see, 0805, 10 volts, 10 UF. Sure, I have those. I only need 2. I think I can pick them out of the tape. Nope. Okay, whatever. But hey, we have decent music, right? So... Oh, Johnny's leaving. Okay, bye-bye. Is it over there? Hmm. Oh, right, that's one of the changes I made. Okay. Okay. I'm trying to rush through this. That's never good, is it? Oh, we're on to resistors now. So I take my little box with resistors, and these are 0805 10Ks. I have those. I need 5. This is really going to be sit back and relax stream, because I can either be building or I can be talking and watching chat, but if I do that, we're never going to be done. So we need a resistor here. You guys are watching out that I'm placing them in the right spot, right? Okay. Dabbing the paste into the stencil? What does that mean? You just squeegee it over there, and most of the time I don't get it in one go, and I try to do it at a different angle, so it should be able to run a thick line on top and then squeegee the whole thing in one swoop. Yeah. C9 is 0.1. So let's see here. Yes. Did I place the wrong one there? I don't know. Where is C9? Oh. C10, C3, C13. Right, that's that one. No, I think I got the right one, Derek. Yeah, okay, I can zoom out a little bit. I just wanted to give you guys a good shot. But it's hard. Oh, I can do it like that. How's that? I think you put a zero, not a 0.1, but that's the same thing. So 100 NF. I'm going to continue a little bit. 0805 6.2. Okay, so those I have over here. Yep. Yeah, that's correct, Richard. Even if I did get them reversed, that's not a big problem. I don't think I did, but... So I need 5 of these. Okay. Let's see here. Okay, I know where these go because, well, I made the design. Okay. Great, ultimate screen layout is found. Right? Yeah, the labeling in the sales screen still needs work. I generally tend to not pay too much attention to it when it's just a prototype I'm making for myself. In the end, the labeling and stuff like that will be done better. And also, if you're doing this yourself, you can just have the drawing big on the screen, and then it's a lot easier to make out where everything goes. Let's see here. 200 ohms. I think I got those here too. Yep. And I need 5 of those. Do I need to make a picture from the board on my desk and then import it, or should I get a file from the website and import that? I'm not sure what you mean, Yo-Yo Skerrit. This is generated from your EDA software. So in my case, this file is generated using KiCad automatically. So you don't need to make a picture or anything like that. That's all auto-generated. 6.2 ohms, are they for dampening the gate? Yes. So there are 2 series resistors here, one for the pin of the ESP to the gate driver, and then from the gate driver to the MOSFET itself. And there's also a pull down in there to pull down the gate on the ESP32 side also. So those are all things I omitted in my other analog board designs because, well, I think if most people would see it, they'd probably run away screaming with the amount of components and it's SMD and oh no and blah blah blah. But if you want to do it right, I mean, those others work. All the lighting in this room is done by those, and those have been working for years. But there's a difference between it works and it's done textbook right. And this is more in the line of textbook right. Which has some advantages in certain situations, so yeah. Yeah, it all, in my case I do it from KiCad, but it's the same thing. It all auto-generates it. So including this little view down here and stuff like that. Okay, I need 3K. Do I have 3K on here? I have 3.3K. Do I have a separate 3K? Maybe. Maybe I do, maybe I don't. I do. 5, 1, 2, 3, 4, 5. So what I do, I generally take it out of the tape and tap it into a certain spot, well, just below what you can see. So I know I have the right amount over there, and then I just place them where they need to go. Oh, these are for the hardware debouncing of the button pins. A set of good tweezers really helps. Okay. I'll maybe tell what the components does. Yeah, well, so I built a custom debouncing circuit in hardware, which consists of a series limiting resistor, a pull-up resistor, and a capacitor per input. So you have the S1, S2, and S3 over here. So that's switch 1, switch 2, and switch 3. Those are actually using input-only pins on the ESP, but that's perfect for buttons. And those three components together form basically a hardware debounce, so that you get less or no erroneous activations, basically. Yeah, it's sometimes complex, but we can talk about it. 0805 1K. Okay, I need 3 of those. No, I can just do it this one. So the 1Ks are the series limiting resistors, so that you cannot pull unlimited power from a GPIO pin, basically. And the 3Ks we just placed were the pull down resistors, or actually the pull up resistors in this case. And the capacitors we already have there are the 100 NF or 1.0.1 UFs. L1 to L5 are hooked up to the big FETs. Yes, so the MOSFETs do the in the end the dimming, and they do that on the minus side of the LED strip, because these are analog LED strip, and you use PWM to turn them on and off really quick. Okay, and then we need a 4K, but I remember from last time I didn't have a 4K. But I believe this is for the LED. Yeah, this is for the LED because it's here up top. So I'll use a 4.7K. I know I ordered some 4Ks, but basically the value of this resistor will determine the brightness of the LED. So I'm just going to use a slightly higher value, so the LED will be a little bit dimmer, but that's okay. Okay, and we just put it over here. Now, as you can see in placement, I basically just make sure it's touching both pads, and not that precise in placement, but generally that should be fine. And during the reflow, we'll see in a little bit, we can still adjust it and change it if it doesn't work out. So, uh-oh. I need to do a little hot swap here. Hold on. I need the box that's under the camera. So let me just do this. That worked. Okay. Because I need an orange LED. Oh, I don't actually need the box that was under the camera. My bad. Then where is it? Is it over here? Yes, it is. Because we need a signature 0805 orange LED. Well, it used to be in the other box, but I now made it its own box. Cool, okay. We only need one LED. And I'm going to cheat a little bit, because I'm going to look on the current board the way the LED is oriented, because it has one side, it has this little dot in here. Oh, you can't see that. There we go. It has one side that has this little dot in here, and another side that doesn't have it. And I know that is the right orientation, so we're going to just do it the same way. Although it seems to be fairly in the middle in this case, but the green dot is on this side. And we're just going to be placing it here. Okay. Could someone newer version of DigQuad wiring diagram? But the diagram doesn't really change versus the old version. What's missing in the current wiring diagrams? No. Once this is available, this is just an HTML file I'll host on my website. You can click on it and then you get this interface. So nothing you need to do yourself over there. Okay, so I think most resistors and capacitors are done. And if I'm looking at the board, I think that's correct. So let's move on to some other components. Let's move on to the smallest component on the board, or rather, the component itself isn't that small, but the footprint, the legs are actually really small. And I'm actually going to replace this in a newer version. But yeah. So this little guy over here, and I'll put it on the board, I don't know, here. This guy, I'll put it here in the white, is an I2C temperature sensor. It is impossibly tiny, but I need to find pin 1. And as you can see here, I don't know if there's a slight little dot next to one of the pins, so I know that's pin 1. And there is also a dot on the board, so you basically line those up and you just drop it on top like that. You can give it a little bit of a squiggle. There we go. And that should reflow automatically in the end. That's why most people are scared of SMD soldering, but some things are actually much easier than through-hole soldering, because all of these components, and you'll see that when we do the soldering, they will actually sort of auto-align. So yeah. Okay. We need 5 gate drivers. I've thought about changing the music, but I like the music too much. Okay, so the gate drivers are these little ICs here. Let me try and get it the right way up. There we go. So these little ICs over here, those are the gate drivers, and they're SOT 23.5, so they have 3 legs on one side and 2 legs on the other side. So that actually makes them pretty easy to place. So you just line it up so that it's pointing the right way. You pick it up and you just place it on the pad. There we go. Come on. Sometimes they don't want to turn over and they keep lying on their back. Okay, and another one. These can only go in one spot, so... Or, well, there's 5 spots, but they're all the same. Okay. And another one. And that's the last one. Should be decent enough. I had not had any components do tombstone yet on a pasted board, but I'm sure it will happen soon. Yeah, I've had it sometimes, but it's okay. Useless trivia. Gate drivers are often needed for MOSFETs as they tend to have quite high capacitance. Yes, that's true. How many footprint courtyard warning does that board have? I don't know, about 8? That's why I build prototypes, Andy, because I need to know if it fits in reality or not. Actually, even if I blow a little bit of air or something like that, the paste, I think it's called capillary action, just makes everything stick. Okay, so I used 3 PDCs. This is one of the things I also changed in the in the newer revision I've already been working on. Because the way I did this, it works, but it didn't really make sense. So I wanted to do it a different way. Yeah, so so it's nice that you like them, Andy, but those are now gone. And I've replaced that with one PTC, but a bigger one, that goes in front of the DC-DC converters instead of after it. I'm not OCD enough to actually line up all the letters and the symbols the same way. I don't want to have it upside down, but other than that, I'm okay. Yeah, Brian says Keycut should create a Quinder add-on to shrink all courtyards by 10%. Living on the edge. Okay. Oh, MOSFET time. Okay. So I do have some here that are from LCSC, but do I want to use these or others? No, for the testing, I want to use these. Okay. I'll build some more boards, or I'll desolder these MOSFETs and test with others. But for right now, we're going to use these. Okay, 5 MOSFETs. Googling QuinLED Dig Quad. I don't know what it is. Wow, okay. Oh, it's not like world known, I think. But if you're following my channel, most likely you would have known about it. Okay. So although on my other boards you can solder these footprints by hand, having paste all the way beneath them certainly does give you a better electrical connection. So to support the higher amps and stuff like that, that is definitely recommended. Yeah, I don't have a reflow oven because I don't generally build really big stuff. And it's mostly prototypes. So, but I do have a hot plate. I do like my hot plate. Okay. I think after this one we're almost done with SMD stuff. Okay. Pause the stream! I need a cider! Okay, that's a connector, pin socket. Yeah. So let's inspect the board real quick. Let's focus that too. Okay. So we're currently checking if there's any pads which do not have a component. So here we have all the components. Here we seem to have all the components. We have the 3 PTCs. This is all populated. I guess I can move this one a little bit. There we go. Down here we have all the components, and actually this camera is working like a little microscope for me. There we go. We have all the components over there. That looks fine. That looks fine. Yeah, that looks good. Okay. I think we have all the components in their right places. Yes, this board also has big fuses. C14 is worrying. C6 looks a bit off too. Where is that? Looking at it, I don't see anything that'll give me a problem. Yeah, no, should be good. The background LEDs stay with the same effect? No, it's working. Oh yeah, I guess I couldn't make a playlist at some point. These are still running an older version of WLED actually. Yes, there is a single LED over here. There's no silk screen yet, because I need to work on the silk screen, but this one is the power LED. And that is powered by 5 volt, so as long as the 5 volt buck regulator is active, that LED will turn on. Okay, so let's move this out of the way and get this guy. And let me see if I can position that on the camera so that it's visible. Let's see if camera can focus on that. Oh yeah, you can see the rings in the in the metal. And I'm just gonna place the PCB on top of there. I have to be careful not to drop it, because now would not be a good moment to drop it. Okay, and let's see if I can position this in a way that it's... no RGB. I actually don't have any pins left on the ESP32. I'm already double using certain pins to make it all work. So this can go away. Well, Andy, when you build your own, you can do that. So I'm going to zoom it out just slightly. Okay. Because we don't really need to see that side of the board. There. All components are now on screen. Let me get a power cord real quick. There we go. And I will turn up. Okay, this can be closed. I'll turn up the light a little bit. Okay. That should be a good view. I have my my tweezers close because we need to be able to make adjustments if something tombstones or something else happens. I have it placed up a bit high right now, but it should still be okay. So I'm turning on the power. Yeah, if they make a new ESP32 with 60 I/O pins, I would use them too. Okay, let me turn it on. And it's currently set to 150 degrees. It's drawing 300 watts from the socket, so it's using quite a bit of power. But the aluminium plate on here is pretty massive, so it takes a while to heat up. We're currently at 29 degrees from 150. So now we just wait. And as I mentioned before, this is 138 degrees soldering paste, so that's considered low temperature soldering paste. That's why I only have it set to 150 degrees, which is actually enough to reflow all of the paste on the board and, well, give you a good connection basically. Yes, hot plate. I don't use it in 3 stages. Maybe if I'd have higher temperature solder paste, so like 260 or 280. But with this 138 degrees stuff, I basically just let it warm up to 150 degrees. At around 120 or so, we're currently at 50, you'll see the flux starting to work. And then at 150, you get a very good melt and flux at the same time. And yeah. You can also make grilled cheese. I wouldn't recommend that while reflowing at the same time. I am going to take my fume extractor here because in a few seconds it is going to start smoking. There we go. So, sorry for the noise, but it is going to start smoking. We're now at 75 degrees. And I can't read the chat anymore. Place your bets on at least one tombstone. Yeah, let's hope not. We'll see. We'll see. C14. Which one is C14? Well, we'll see. Okay, we're at 106 degrees right now, and there's starting to be a few plumes of smoke. 112. Yeah, 115. Okay, now I'm not sure it'll show. You can see it on camera a little bit. You can see some smoke coming off. That is the flux activating, so that's good. Okay, now there's more smoke. Okay, we're at 125. C14 is in the middle. Okay. Okay. I'm starting to see some paste soldering. Yep. Paste is changing to metal. Or to a soldered connection, basically. So we're at 140 now. And let me see if there's anything out of order. C14. C14 looks fine. So once it's melted like this, and we're currently at 146 degrees, if you want to make sure a component is aligned correctly, you can actually just give it a little nudge like that. Okay, that was too much of a nudge. And it should auto-center the component once you touch both sides of the solder, basically. You can see that? So even C14 looks fine. This one... yeah, looks fine too. Looks fine too. Looks fine. MOSFETs. Oh, yeah, well, moved that one a bit too much. But it pulled itself back. Yeah, that looks fine. Over here we have a little problem. You see this capacitor over here? That scooted over. Okay, that's fixed. Let's see if we see any more issues. Andy's losing his mind with R20 upside down. So it's still smoking. That means we still have flux that's being burned. That's fine. But since I'm using the low temp paste, we can actually leave it like this for a while we check that everything is soldered okay. I don't see any issues anymore. No, that all looks fine to me. Yeah, that's fine. That's fine. Yeah, looks good. R21 is a tiny bit close to the FET. Where is R21? I don't see it. Yeah, but I don't see any issues either, so it should be fine. Crank it up to 220. No, why? Why? I'm just going to take it off now. It's done. So, trying to get a good grip. putting it back on my onderzetter, my IKEA onderzetter. I'm turning off the hot plate. Okay, and let me move that out of the way. Because this hot plate has a massive aluminium plate, that stays warm for quite a while. So let me turn the fan off. And, oh, well, we're going to be needing this fan in a minute. Okay, so let's take a look. Oh, well, I can see the resistor you mean right now. That is pretty close indeed. Okay, it's not hot enough to reflow anymore, but I'm going to put it back on the plate. Oh, on the plate. I dropped it. But I dropped it on the plate, so it's okay. The plate is probably still warm enough to remelt that solder. So let me see if I can give it a little scoot. Yeah, there we go. Yeah, okay, you couldn't see that, but I'll show you in a second. So I didn't have to turn the plate on again. See, I scooted it over just a little bit by placing it back on the plate because the plate's still warm, basically. Now he's going to notice C14 too. What? C14. No, C14's fine, I think. Oh, no. It wasn't cooled down yet. Okay, it needs to go back on the plate. Damn it. I touched it. Okay, let's see if we can move C14. Okay, I think it's stuck. Oh. Now you guys... Oh, no. I dropped it again. See, now you guys are making me nervous. Okay, let's get this on screen again. But the board is hot, so I can't really touch it. There, I fixed C14. Yeah, so this was leadless solder paste because I used the expensive Quick Chip stuff. Quick Chip? Chip Quick. But for the normal soldering, we are going to use leaded solder because it's just easier to work with, and these are all prototypes. So, and R21 is clearly not touching the FET. Yeah, I moved it. Now it should be fine. Now it should be fine. I mean, I did prepare my... Yeah, if you look at it like this, you can clearly see R21 is not touching anything. Can we actually use the little one? Yeah, see? So this is R21. R21. And that's fine. That's not touching. Let's check the legs of all those SOT 23.5 packages. But that all looks fine too. Yeah. Yeah, looks good. Oh yeah. Yeah, you need a bit higher temperature for leadless solder. But this chip quick stuff, it's 20 euros a tube, but I mean, the hot plate never got hotter than 150 C, and it melted perfectly. So, yeah. Yes, actually it is, Patrick. So, it would be fine, but, you know. Yeah. It's all looking good to me. There's some solder balls, but that's okay. And even this guy looks to be reflowed correctly. We'll notice that later. Yeah, chip grip is a bit expensive, but especially if you want 138C paste and stuff like that, you kind of gotta pony out for the good stuff. Pony up for the good stuff. But as I said, for prototyping, it's perfect, because if I want to change something, it's really easy now. Instead of using the 250 or whatever C paste, you'll basically melt everything inside. Okay. While that is cooling off, basically, I'm going to prepare the screw connectors we're going to need. So let me get those real quick. Right, there's a lot of different types in this box, so I'm gonna have to move this. Sorry about that. I guess I can show you my box of screw connectors. Oh, you get to see my mounting mechanism too. So I have a giant box of these pluggable screw connectors over here. So I need to find the right ones. I believe I need these, yes. And I need these, yes. And well, we already had some smoke escape, but it wasn't intended smoke, so okay, we need one of these, yes. So it was less magical because it was intended smoke, but still there was smoke. Two of these. And intended smoke is no smoke. So let me start putting these where they need to go. Oh, yeah, I just need one more. Where did I put it? I put them over here. There we go. Now I just need to be able to close this box again, which is always a bit of a challenge. I don't know. I need two of these boxes almost. Well, there's lots of tutorials and videos and stuff like that online. I don't really do electronics tutorials myself. But there's lots of resources you can find online. Okay, this box is not closing at all. Well, that's fine. We'll take it. Okay, so we have all the screw terminals now. We need some fuse holders. And, I have a big bag of fuse holders. Yeah, and we have the PCB design talk. That's true, but it's not really the learn how to design from here channel. But if you have certain questions and stuff like that, those are certainly welcome. Okay, screw terminals. Good. And then we have a lot of pin stuff. Let me put on my headphones again. For some reason, when I'm streaming and I don't have my headphones on, it almost feels like I'm not streaming anymore. I don't know why. Okay, this is all used and done. It's fine. Yes. Okay. These are going to go here. Then we need a 7-pin header, I believe. Yes. Yep. And then we need 3 times 3 pin headers. So we're going to break those off. So I just have these strips of 40 headers, and I just need 3 strips of 3. That's 3. That's 3. And that's 3. And I believe that's all the connections on the board. What do you guys think about advanced DIY so far? Is it doable? Do you think you could do this? Or are you screaming inside of your head, where are all the through-hole components? Can't we make all this from through-hole components? No, you can't. Then this board design is completely impossible. It has to be twice as big. But okay. I think that is all the components on the board. Nope, that's the wrong way. Oh no, don't do that. There we go. Let me try and lift it up. So, stuff that the boundary on KiCad doesn't agree with is like here, this connector is brushing almost against these fuse holders, and these 2 connectors will also give warnings, and this will give warnings, and lots of warnings. But in the end, as you can see, there's actually some wiggle room left, and fits fine. So there's always a difference between theoretical and reality in that sense. Yeah, the tipping over of the iced tea also looked easy. Yes, the 0805 stuff could be done with an iron. These gate drivers are already a little bit more difficult with an iron, but it can be done with plenty of flux and stuff like that. But for instance, this temperature sensor, that's impossible with an iron because the pads are below the object itself. And you can do these with an iron, but you need to know what you're doing with the MOSFETs, because otherwise you won't get a proper bond to the board in the same way that the paste does, basically. Because it binds the whole thing to the board, which also provides heat sinking. And that's just more difficult to do with an iron. I'm not going to say impossible, but yeah. Yeah, well, I like stencils, and on PCBWay they're about $10. Don't get the one with the frame. Get the non-frame stencils, because otherwise you get a giant sheet. Yeah. So the way I'm going to approach this is basically what I do is I look for the highest components, and those go on last. So it looks like the sockets for the ESP are the highest. So we're going to take those out. And then the pin headers are the same height. Oh, so we're going to take those out. And then it's these. So the screw terminals. The big screw terminals, I have to say. And then the fuse holders are also higher than those other terminals. Okay. So we're going to solder these first. But I'd like to balance the board on the other side a little bit. So I'm going to take one of those terminals. And I'm going to put it like this. So this one has pins, but I have those facing outwards of the board. And then I'm going to pick up the board like this. And I'm going to take my onderzetter, put it on top, and apply pressure. Oh no. And screw it up completely. So let's do that again. Nope. I might need more than one of these on the other side, but we'll see, we'll see. So apply pressure, keep applying pressure. There we go. So now we have it turned around, and since we have a counter balance to the board, we can press it down, and we know that the sockets and holes are all perfectly aligned, basically. That's a little technique I use. I don't know if you do it differently, but that's what I like to do. Yes, you definitely must buy an IKEA onderzetter before I get all the components. Well, it's part of the components, I guess. There's other ways you can do it with third hands and stuff like that, but I like doing it this way. I really love his self-closing tweezer for this. They hold the component in place, no need to juggle the board and the onderzetter. Yeah, sure. Are there going to be lots of different features between pre-built and DIY? Currently, I don't have any special features in mind for the pre-assembled. It will look very different because I'm currently using pre-made modules for the DC-DC conversion. I'm using 3 of those, and on the pre-assembled I'll make my own circuit for that, and so that'll look different but provide the same functionality basically. Okay, so I recently changed the tip on my soldering iron, or actually I changed the whole handle, so including the heating cartridge. So let's see how that works out, because there is some massive copper planes on this board, which are going to be a bitch to solder. But we're going to see. We're going to see. When I did my last prototype of this one, I actually used a hot air gun to heat up the board and then apply my soldering iron to it to be able to get enough heat into the board to be able to solder the connectors. But yeah. Yeah, I believe so. I'll need to check that in a minute, Arjen. What? Discord messages? What's going on? Oh, okay. Right. So let me move some stuff here. Okay, this is all good. I didn't put the board far enough. Let's see if I can move it. Worked out. Cool. Okay. I'm going to turn on the suction again. Oh, you mean this one? Yeah, that's just for stabilization, for soldering it right now. Sometimes I get knots in my soldering wire. No clue how that happens. There we go. So these should be very easy to solder on because I say that and I see a ground plane because these don't have a ground. Oh wait. I don't like getting flux and stuff in my eyes, so I wear a little safety goggles. Because the flux can splatter, and yeah. There we go. You can zoom in a little bit more if you want. So those were the easy connections. Let's see, 5 volts shouldn't be too hard either. But then we have ground. Oh, okay, that worked out okay. Okay, there we go. Is it okay like this, or should I zoom in a little bit more? I'll zoom in a little bit more. Right, so now we have these in place, and since we balanced the board with the same component on the other side, they should be nice and straight and be correctly on the board like that. So I believe the next are the bigger screw terminals, and those are going to be a pain to solder, but we're going to try. This is actually the wrong one. Okay. Yeah, you can do the one-pin solder trick. I do that for the other stuff, but for these that wasn't necessary. So these are slightly higher than the others, so that's good. And I'm going to try the same trick again. There we go. And this should all be pretty well balanced on the board again, because these are now the highest points and the others are floating above it, so... Yeah, you can do the one-pin trick. We'll do that later with the pin headers. But for these, I can pretty much see the orientation and they should be fine. So let's do the L... yeah, this is all connected to giant copper planes on multiple layers. So let's see how that works. So as you can see, the blob isn't melting. So you just need to keep applying heat. Oh, there it goes. A little bit more, I think. Yeah, the solder still isn't perfectly melted. That's decent enough. I'll take it. Okay, let's do the other one quickly because that is connected to the same plane basically. So the smoke coming off is the flux burning. Ah, okay, that soldered well now. So let's do the other one real quick. Add a little bit of flux there. Okay. So see how it did? It's less of a bulge now, and it's more of a, I guess, a tower or a pyramid around the terminal. That's perfect. Okay, let's do these. And these again are also connected to giant planes, so just keep your iron on there. It's going to take a while. Yeah, beefier tip, but this soldering iron is kind of at the limits. I have been looking for a different one, but I haven't decided which one yet. So just like the first time, I'm going to keep applying heat, and at some point it should snap into place. And even if it doesn't, I'm going to move on to the next point because that is connected to the same plane. But this now already has heat in those planes. So that should melt a little bit easier. Just keep heating up that board, that's fine. Okay, that looks better. Add a little bit of solder here to add a bit of flux. There's a bit bit too much solder on there, but it'll work out. Okay, on to the fuse connections here up top. Again, big planes and stuff like that, but smaller than the other ones, so should be a bit easier. There we go, took it in. You can see when it sucks in the solder and it's melted enough, right? So it first balls up like this, and then once it heats, wait for it. Come on. There we go. You see it kind of suck in the solder. That means you got it hot enough and it went everywhere. Yeah, those are the same style I have now. So with the ceramic heating element and then those little tips. But I'm maybe looking at a cartridge style, like maybe even a JBC or something like that, because well, I do a lot of this stuff. So it might be warranted to step up basically. I think there's too much crap on my iron. There we go. So it should form a nice smooth mound around the pin. Oh, the T12s are cartridge? Okay. Yeah, I've been looking at Metcal and JBC and really stepping it up basically. But yeah, those are expensive. You'll easily pay like 400 or 500 euros for a station. So that's why I'm debating it. I mean, this also works, so... But I want to try maybe do more leadless stuff, and then cartridge and higher power really makes a difference. Okay, that went pretty well. As you can see here on the back of the board, there is spots for diodes. We're not going to be placing those. Those basically aren't important if you're doing LED driving. But if you do different kind of loads, such as inductive motors and stuff like that, I've made spots for those that go back to the capacitor and the fuses and stuff like that, so that you can maybe still use the board for that, but generally for LED driving those aren't needed. You're a pro, get a Weller. Maybe. Oh no. Okay, I didn't have this connector sitting right. This one is slightly tilted down, as you see. It won't affect functionality, it just looks a little bit less pretty, but it's okay. Make it work. So I believe the next are the fuse holders. Is the audio still okay with the air suction on? Wouldn't have happened with the self-closing tweezers. Yeah, I guess. Okay, now these the footprints are custom for these fuse holders, and they're tight enough that they basically hang in there. And again, it's a question of applying heat. Let me... Okay. Yeah, I know, Bart. I know. I should have listened, but... Generally, these connectors work out okay if you balance it on both sides. There we go. Applying heat, applying heat. Yeah, this is still a ceramic style soldering iron, so no cartridge. So it's not that great at delivering peak heat. But it'll work in the end. I know, it's okay, Bart. There we went. There we go. A little bit more here. Okay. Oh, that's going into the connector. Come on. There we go. Okay. So let's see on the top side. Oh no. I think there's actually solder that went into the connector. Maybe it applied a bit too much heat. Let's see if we can still get a fuse in there. Yep, we can. That's okay. It'll work. There we go. But can you see here that there's solder inside of the connector now? Oops. But as long as the fuse goes in, that's fine. And I mean, the gap is still there, so it doesn't affect functionality. Slurps right into it, yeah. Yeah, as I said, this soldering iron is now 5 or 6 years old, and I've used it pretty much. I did get a new handle and a heating element now, so that really helps a lot. But yeah. Okay, let's do the pins, and here I am actually going to use the one pin first and then checking method, because it is somewhat important these go straight. What time is it already? Oh, it's 11 o'clock. Okay, that's okay. Okay. Yeah, true. But, you know, sometimes you have to make do with what you have. Oh no. Can I move it? No, I really can't. Okay. Have to do it again. Yeah, so the height differences aren't that much in this case. So it's hard to get it right. Especially like single row pin headers. They just really suck. Okay, let me try that again. Okay, at least I see all the pins now. Yeah, we're getting there, Bart. We're getting there. So, for these, I'm just going to do a single pin, like that. Of course, I always hit a ground pin. Okay. And this one. There we go. Okay. So now we can take the board and we can check how we did. So this needs to be pushed in more. So what I do, I just apply pressure. Okay, there we go. Is that correct? No, it's not. Now it's correct. Okay. That's slightly crooked still. Jesus. Still not perfect. Damn. Okay. Yeah, so now the big ones are okay. Use jumpers on them to keep them up? How do you mean that? Oh, you can plug an ESP. Yeah, sure. That would have worked. That's true. But I do it this way, so I just put my hand on it and I reflow it, and I try to get the pins basically lined up in the middle of the holes. And generally when I do that, that works out okay. Now these these are really at an angle. So let's see about that. Oh yeah, okay, sure. That's a good idea actually with the jumper. But for now, I'll do it this way, and I can line them all up. You just have to be careful not to touch the pin you're actually desoldering, because they'll get hot. Okay, that looks pretty good. Maybe this one slightly like that. Yeah. The Leaning Tower of Quindor. Yeah, so those now look fine. So then we can solder all the other pins. And I'd redo the original pin you used for adjusting, just to make sure it's soldered correctly. That is definitely the ground pin. Oh, come on. Come on, take it. Of course. There we go. Just want to make sure this middle pin. Okay, there it goes. I'm doing this in slightly awkward angles at some points. Okay. It's so much easier to get ideas when I'm not soldering. Yeah, I get that. Okay, that looks fine. Let's see if it looks fine. Yeah, that looks fine. Okay, next. We do the big pin headers, and that should be it for soldering. Hello? Let me do this differently. Let me do it this way. Okay. Thanks, Andy. That's appreciated. And then I'm just going to do it the other way around. Oh, too much junk. It's not. It's not the best job ever, but it'll do. Wait, no, don't do that. Yep, looks okay. That looks okay. So we have all the pin headers soldered. The D125 we leave open, that's fine. Then on the top we also have everything soldered. We're not going to solder this capacitor for right now. For normal usage it shouldn't be needed, but I wanted to have a space for it if I wanted to, or if you indeed want to run an inductive motor or something like that. So there's only one last thing we need to solder, and that is the voltage regulators. And I need to find 3 of the right ones. No magic smoke yet, so we need a 12 volt one. That's a 9 volt, we don't need those. Yep, we need a 5 volt one. And we need a 3.3 volt one. So this one is 3.3 volt. This one is 5 volt. And this one is 12 volt. So they all look the same. What are we talking about, Guido? No thermal relief. Yeah, there is some thermal relief, but if it's connected on 4 planes, for instance for ground and stuff like that, it's still a lot of mass to deal with. Okay. Now we need to use a little trick again, because if you look here on the board, you see 5 volt, 12 volt and 3.3 volt. And let's make sure we get them in the right spot. So this is 12 volt. There we go. This is 5 volt. Let's check that. Yeah, 5 volt. Yeah. And this is 3.3 volt. Okay. And there we go. Seems a little bit crooked. Try and bend it in a little bit so that it's straight. There. That should do. But now we need to make sure it has the right distance. And how did I do it last time? I think I just used some pin headers. So let me get some pin headers. Ow. Still need to find a better way to do this part, but I haven't been able to think of one. So let's get 2 little pin header thingies. And, well, the only thing I thought of was if we take the board and we just basically drop the pin header and push this below it, that will raise it up basically to the height we want it to be. So that it's basically straight in the air and not touching any of the other components. And then I'll start with soldering one of the pins. Okay, that didn't work out. Okay. And while that is soldered or melted, I'll straighten it out so that it sits correctly, and then I can remove the pin header and that's fine. So now I can do the other pins. No, don't do that. Okay, whatever. So this part is a bit tedious. Come on. There we go. Okay. Okay, that isn't touching anymore as far as I can see. Yeah, that's fine. So the other ones we do the same way. I don't use the pin header anymore because that was just a guide. But what I basically do is I melt solder onto one pin. If it wants to take it, which it doesn't. And my previous iron handle had a chisel tip. That is absolutely easier for this type of work. Ah, stupid. I might need to add some flux. Let's do it this way. There we go. Okay. So then, while we melt the tin again, we basically lift it up until it solidifies again. There we go. So that it isn't touching the components that are beneath it, basically. And then we try to do the rest. But it's kind of hard to do this and show you guys. So I'm going to move it around a little bit. Okay, and now for the middle one, which is a bit of a challenge, because my tip is too large. And there we go. It's a bit crooked, but it'll be okay. Last one. No. Okay. Yeah, so I might need to think of a better way of doing these. But I haven't found one yet. Oh, crap. Okay. I really don't want to get the flux. I think I got it. Now I think I also moved this capacitor, but well, I can move it back. Well, I don't actually think it's touching. Let me check. Yeah, so all the pins look good. Where's the pins? There we go. So those are not touching. That's fine. Those are not touching. That's fine. Those are not touching. That's fine too. And these capacitors are really close, but I didn't melt the other side, so I think that was always the case. I think that should be fine. Okay, let me turn it around. So we did all the big terminals. We did the small terminals. We have the socket for the ESP32. We now have the voltage regulators, and the idea is that these are now basically kind of floating, because there's capacitors and resistors beneath it, but they are floating up a little bit because we did the one pin trick and then lifted it up, so they are floating in the air, but they don't weigh anything. So once with 3 soldered connections like that, they're not touching anymore. I mean, this is really close above the MOSFET, but if you look at it like this, you can see there's enough room there. Like that, they're not even close to the components. So, well, that's what I thought of to get the design as compact as possible. I might still drop one of these regulators, so I might go with a LDO that I can solder onto the board instead of having a 3.3 volt regulator, because we're not using that much 3.3 volt, but not sure yet. This is a very good solution. So if we're talking about having it the ultimate way, having a regulator for 12 volt, 5 volt and 3.3 volt is certainly the better way. So what do you guys think? Should I change it up to have a regulator, or should I keep it this way and basically keep it the ultimate board? 3.3 volt is needed, for instance, for the I2C sensor, and I also have a 3 volt output, or 3.3 volt output, if you want to connect other sensors. The button pins are all pulled high with 3.3 volt to the ESP module. Yeah, so I need 3.3 volt. I just don't need that much of it that I couldn't use a regulator, probably. But I need more of it that I want to use the onboard regulator for the ESP32 board. A Penta Mini, but I wouldn't get smaller from that. Yes, the ESP32 board, it has a regulator for 3.3 volts on board. That's this little guy here, but that is designed for the ESP32 board and not so much for running much more stuff extra than the board itself. Sure, you can run some sensors or some pins and stuff like that off it, but if we're building a board anyway, for instance, the screen also runs on 3.3 volts, and I wouldn't want to run that off of the regulator on here. Yeah, I'm not going to put on the big capacitor right now because I'm not going to do any inductive load. And for normal LED operation, it shouldn't be needed. I made a footprint for it because I wanted to do some tests with it to see if it could lower PWM noise and to see if it had an influence on the waveform that comes out of the MOSFETs. But I'm still doing testing in that regard. So for now, it's a footprint I wanted to have on there. So I could put one on there, and I did put one on there on this one, for instance. So now I can compare between the boards and see if it influences the waveguides or the waves with an oscilloscope, and if it changes anything in regards to the quality of the signal or not, and decide if it's needed or not. So yeah. Well, this one is already configured, this ESP32, because I've been working on the ESP30 or the ESP home code. So let's run through the ESP home code and then just turn it on. So let's get some fuses in there. No, there shouldn't be. CJ, I currently don't have any features in mind that would be on the pre-assembled, that wouldn't be on this DIY version. But it might look very different. As in, these 3 add-on boards that are on here now, I'd probably do that in my self-designed circuit, but then use 0402 components instead of 0805 and stuff like that. So lots more tiny components and stuff, because the machine, the pick and place machine doesn't care, because then I can just fit on more, but it'll have the same functionality in the end, basically. No ground short test. Sure, you want me to do some testing? We can do some testing. Let me plug in the plugs first. So we have a plug here. This is 4. These still need to be unscrewed. This board is a 5-channel. We didn't need that one. 5-channel analog dimmer board, so it does PWM dimming. Shouldn't I have more plugs? Okay, did I clean those up when I did? Oh, here's one. And on here, oh, I can use these. It is possible to zoom out a bit more. And now the soldering is done, that's fine. Okay. No, this is also 4. Why do I have so many 4s? Why do I have only 4s? Ah, here's a 5. Okay. Let me unscrew this. What frequency does it reach? It should do about 300 kilohertz if you want it to. Running 2 dig quads in the kitchen now, so turning that into one board would be awesome. Well, that's a very different board, and it doesn't work that way. This is an analog dimmer board, not a digital controller. I don't understand where that plug went. Oh, here it is. Yeah, I can use this one. Okay. Oh, I seem to have lost a screw here. Oops. Don't see it. Well, it's okay. We're not going to use that right now anyway. Right. Okay, let me remove my big board here, because it's in my way. Yes, they are. So, let's get some LEDs. Is my plate cooled off? Yes, it is. Okay. Let me move that out of the way and get a power supply and some LED strip, and then let's do some testing. So let me zoom it out a little bit more. Because, well, here's the power supply, and I've already been testing with this one. And we have two black wires, those go to ground. And then we have two red wires, and those go to positive. Right? So I can move this off of the screen. And, well, I already have 5 24-volt warm white LED strips hanging in my office. It's kind of hard to show you, but I'll try with that camera in a little bit before I turn it on. So I'm going to remove these plugs because we're just going to use my testing plugs I already have in here. So this one goes here. That is 5 different strips. And this is also 5 different strips. But one of the plus terminals are basically abused. And there's 2 in there. But yeah. Because these terminals are generally big enough to get 2 wires inside at the same time if you want. What? Why would David Watts be apologizing? Let me try and get a little bit more slack here. There we go. Oh, destroy my lighting system. There we go. Okay. So let me show you those LED strips I have hanging here. And, okay, let me get a little bit more slack even so that I can also have them in the shot. Yeah. Right. Of course they're all turned over. Why you do this to me? Okay, trying to line these up. Hold on just a second. Otherwise, later I can also hook up an RGB+CCT strips, because that's why we have 5 channels. And last one. Okay, so now we should at least be able to see all the channels individually. Except for LED strips that have so much copper in them, they want to go anyway except the one you wanted to. Okay, let me take that camera real quick. And I don't have too much maneuvering room, but we'll try. So let me take you up here. And all the cables are... Uh-oh. Yeah, so there's those LED strips. Those basically go up, and they go up to my ceiling, and then they either hang down again over there, or up there. Oh, there's the top camera. Hello. With lijmtang. Lijmtang is awesome. Anyway, so yeah, again, from the board, they go up to my ceiling, next to my lighting solution. All the way up to my ceiling over there. Don't focus. So yeah, I hope that explains the test setup a little bit. I can hook up an RGB+CCT strip later, so we can toy with that too if we want. Okay. Let me focus. Oh. There we go. Okay. Okay, I hope that explains how it's connected. So then let's quickly take a look at ESP Home, because we first have to go to my testing setup. Okay, let's see here. Chrome. No. Right, so this is my my test Home Assistant server, and we're going to take a look at ESP Home, and then we go to the test An-Penta, because, well, this is the An-Penta board. And over here we have some basic configuration steps, nothing too interesting. I have I2C configured for the temperature sensor. I have SPI configured for the onboard screen, but we don't have that plugged in yet because on this prototype the pin order isn't correct. I can make it work using DuPont pins, but it requires some changes. Then we have 3 binary sensors, and those binary sensors are connected to those S1, S2, and S3 pins that have their own terminal. So those are switch pins. They're pulled high, and when you connect them with a little wire to ground, that basically activates them. And you can do things like toggle, like for instance I have said here, toggle channel LED 1. But you can also do momentary presses and long presses, short presses, and connect different functions to those if you want to. But right now they're just toggling an LED channel. Then we have our output channels, and those are defined to these pins. I've specifically chosen pins that do not have a function during boot up, so that there's no flickering when you turn on the controller or reboot it. Then we have the definition for in Home Assistant, so we set up the LED channels. I do some gamma correction to get a better low end basically, and I have it set to 3 seconds fade time between values. Okay, then I have 2 temperature sensors configured because I was testing with some stuff. Currently we have the AHT10 on the board, but that's likely going to change to the SHT30 in a future revision. And then, well, I have lots of more stuff in here, but we'll talk about that some other time. Okay. Now this should already be on this ESP32. So let's go back to the board view. There we go. Let's try and get it in the shot and see if it explodes. Because the proper thing to do would be, as someone suggested, testing with a multimeter, getting my bench power supply, current limiting it to a low value, and then turn it on and see if it works and doesn't explode and stuff like that. What? Yeah, Lime Tongue is awesome. Yes, lots of wires, but hey, we'll see. Well, you thought I had a perfectly built out studio with all wires hidden? It's wire central over here. Anyway, yeah. I think I'm just going to turn it on. I hope I didn't mess up the voltage regulators. That would be bad. Let's see. This looks fine. This looks fine. Yeah, we're in YOLO mode. Let's go. Okay, you can see the LED strips, most of them, except this one. I don't know. Let's do it that way. Sure, whatever. I'm just going to hit the switch. And I'm going to stay close to the switch and go back a little bit. Okay, nothing's happening. Why would nothing happen? That's all soldered. This is good. I'm going to try it real quick without an ESP32 on there. Is the power supply on? can't actually tell. Okay. Let's disconnect more. And let's just leave this connected. And see if that boots up. 0 watts. Okay. Wait. Maybe I should plug in the right wire for the power supply. Yes, 3.3 volt, 5 volt and 12 volt regulators, but I'm using 24 volt LED strip. I had the wrong connector plugged into my socket because I changed the power supply and I didn't connect it. Okay, but it's good. Maybe it's good to just turn it on like this and see what happens. So let's do that. Let's do that. Ah, yes! Power LED. Much better. Okay. That looks okay. Let's turn that off again. Let's put the ESP32 on there. Oh, it had some residual power. Okay, let's turn it on. Okay, nice. Power LED for the ESP32 turns on. So that's already better. That's good. Let's see if we can reach it in Home Assistant. We should be able to. I'll share the screen in a minute. Hold on. So it takes a little bit before it becomes available in Home Assistant, but it should show up in a minute or two, second or two. I can check if it asked for DHCP. Yes, it asked for DHCP. Let me check if that is the one that is currently assigned to this DNS. Ah, there we go. Okay. Home Assistant found it. So now we have an uptime timer. And we have temperature and humidity. So that's already working. Okay. It received a value. Okay. And let's go back to this screen then. So now the ESP32 is already online in Home Assistant because I had the configuration and stuff like that prepared. So that's good. So let's turn power off again. And let's plug this in. And I didn't check the LED strip if those aren't shorting anywhere, because I haven't used those in a while. It's gonna be fine. I hope. Let's not do it this way. Yes. Klabam! Klik, klik, klaar, volgende project. Yeah, we'll see. Okay. Yeah, let's do it. Okay, it's still turning on. It's good. No LEDs flickering or nothing. That's fine. Let me add the browser back in here again. There we go. Oh, okay. Sure. Sure, that's fine. Ha! That's a giant browser. Okay. Channel 1. Oh, it's working. You can see the amount of light. I mean, holy shit. These are all high power LED strips. Okay, channel 1 works. Yeah, channel 2 is working also. Channel 3. Yep, that's a different color. Channel 4. Yep, that's working. And channel 5. Yep, that's working too. Great success. Nice. Phew. I mean, you guys were all here while I built it. but it's very satisfying in the end if it actually works. Okay, so yeah, we can now do things like, okay, let's go here and let's turn it up slightly. And it always does a 3-second fade between the different values. So I can put it up high and then it fades up high, and I can put it up low and then, you know, it's fading nicely. Let's turn it on full power. Okay, turn it down again. Oh, no, turn it up again. So what we could do, because, you know, we need to see if it actually really works. Let's turn this one fully on. And then turn it off again. Let's turn this one fully on. And turn it off again. And again. And off. And on. Okay, and off. Okay. Oh, Philip is here. People will not stay subscribed if you're going to keep the magic smoke to yourself. At some point it'll happen again. You know, I can't predict when the magic smoke's going to be there. But we can do a magic smoke test. And yes, it is warm in here. But this temperature is more the temperature of the board than so much the temperature of the room. But it's definitely like 27, 28 degrees in the room too. So now we're going to turn on all channels to maximum value at the same time. And these are all 28 or 24 watt per meter LED strip, and then the full 5 meters. Yeah, I don't know for the new boards, maybe like 50 or 60 degrees, something like that. Oh, for the analog quad, yeah, that's hard to say. Is it in an enclosure? Is it free air? Yeah. Don't do it, man. No, we have to do it. We're going to look straight into the camera, which I'm going to turn a little bit. There we go. And so we're currently at 4 watts idle. That's idle usage of the power supply. The board is using less than a watt, but you know. And I'm just going to hit it. I'm just going to hit all of them. 1, 2, 3, 4, 5. Oh. It's really bright here. We're using 360 watts. Holy shit. Okay, I'm turning off the beacon now. Okay. And you have to remember, I'm already in a studio with studio lighting, so it's pretty bright in here, because, you know, I was soldering and stuff like that. You don't do that with a little amount of light. So it was already pretty bright in here, but turning all of these on to full power is just like, make it stop. No. Okay. Yeah, that makes a bit of heat. Lightouts once they're bulb back. Yeah, for sure. Yeah, and of course that also raises the board temperature a little bit. As you can see here. But that's normal, because the board, whatever traces you are able to make, will have resistance, and resistance generates heat. But, you know, this is more than 350 watts of LEDs, so... Oh, the Wi-Fi signal's pretty good too. Anyway. Your circadian rhythms are going to be blown for a little while. Yeah, likely. Okay. Yeah. That works. I've already been testing with the other prototype I made with my FLIR camera, and that's all looking very encouraging too. As I said, I want to make some small changes to this prototype still, but it's starting to get there, and main functionality is already working. Oh, I guess I can show you the button functionality. So, if we take one of these switch pins, for instance, this one, and I connect it to ground, like so, nothing happens. Why not? Oh, there we go. And I can do it again, and it turns off. And if I take, let's try and show you guys. If I just jam it into the terminal here, and then touch ground. Nope. Oh, this is working great. Yeah, okay, I'm not touching the terminal right. What is going on? Okay. Yeah, so I need to hook up the wires better. Let me get a 2-pond cable. Nope. Nope. I don't have a 2-pond cable. Oh, this one is better. Okay. Oh, right. Yeah, because so if I click it in HA, it immediately responds. So click, click. And as I said, it's currently just set to toggle. But if I actually hold it in, that actually does register, but no action is configured right now. So it only initiates once I release it, then it sends the signal. So I can just do a click, 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 click. Why isn't this one going? Oh, there we go. Anyway, yeah. So, button pins are also verified working. Let me turn this one off manually. And temperature sensor is working, but as I said, I want to change this one because it's probably not going to show up on video, but I've actually talked to Andy with this already and Philip. This temperature sensor causes flickering during the dimming of the LEDs. Once it's set to a certain point, it's fine. But if it's going up or down, the code is basically conflicting and it's causing a little bit of a flicker action during that code. And the source is actually the code for this temperature sensor. And using the other one I have in here, but it's the SHT30, that has much better code for it, and that it doesn't happen. So I'm probably still going to change that out. But yeah. Sunglasses, yeah. No, I've actually done better tests, and the debouncing is working perfectly fine. It's just there's very tiny little screws here and not touching it right and stuff like that. But yeah. Why not 5 button pins? Because you have 5 channels. Because there's no ESP pins left. That's basically the reason why. That's not fully true. These 3 terminals over here, these can be used if you're not using Ethernet. If you are using Ethernet, you cannot use these 3 pins over here. So that's a limitation. And these 2 pins cannot be used if you want to use the temperature sensor, because the I2C temperature sensor on board is linked to it. But you can hook up other I2C stuff. So if you really wanted to have like 16 buttons, you can hook up one of those I2C I/O expanders to these 2 terminal, SCL and SDA, and then you can have 16 buttons if you want to. So yeah, you can use those buses for that and stuff like that. Or you can multiplex the buttons. Yeah, sure. Yeah, the temperature, if the board gets hot, I mean, the temperature sensor is on there to measure how hot the board is, not the environment. The way it's implemented really isn't very good for measuring environment temperature. If you want to do that, you basically take what I have here, and is one of these breakout boards with a temperature sensor on it. You hook those up to the I2C terminals and the 3.3 volt and the ground terminal, and this will sit a little bit further away from the board, so then we'll measure the temperature for the room accurately. But yeah, the temperature sensor on the board specifically isn't meant for room temperature. Shift register, yeah, Phil, you can use a shift register or like an MCP2317, or there's various other I/O expanders out there that you can just hook up to these I2C pins, and then you can have all the pins in the world. Oh, Dave asks, is there something like a mailing list, or how do I know when it is released? It's a really impressive board, and I really like stable Ethernet. Great work. Well, we can hook up Ethernet, actually. Let's do that. I think my Ethernet configuration that was in there was working, because I was toying with it, but we'll see. Oh. Yeah, so Discord, you'll always know the quickest and the soonest, and once things actually get released, I of course will make a video about it too. But Discord is always the people who are first in line. Oh, I'm using one of those really tiny or thin Ethernet cables. So far it's been fine. Of course I'm not doing PoE, but you know. It's actually thinner than my power wires. Okay, yeah, let's turn that on. Not sure what configuration that's running. Oh, I'm really not sure what configuration that's running. That shouldn't happen. Let's see what I did there. Let me see if this is asking for an IP. Yes, it is. It's not online yet. I'm not sure what the flickering LED strip is about. But that's probably a configuration issue. I'm going to stop sharing my browser for a little bit. And I'm going to check that configuration out real quick. But I don't think I took the passwords out of that one. They're from my testing network, but still, you know. Let's see if I can flash the new version that I prepared. Disco! Oh yeah! Not sure what configuration is in there. It's interesting. It's clearly some kind of data signal on there. Well, I'm compiling a new one and trying to see if I can OTA upgrade it. Because I might try to run a certain test on it. So during testing of the board, it's funny, but actually the terminals were getting the hottest during a 20 amp load test. So because these are the pluggable terminals, that's the reason I also don't use them on the dig boards, is they're not really good at handling lots of current. Okay, I need to fix some IP stuff here. Let me check real quick. I think I know why it's flickering. That's because I put WLED on there. Hey, do we want to try running WLED? We can do that. We can do that. And let me just turn the browser back on. There we go. That's WLED. And let's see. Let's kill all configurations in here. So let's see. I guess this is white. And I need to check which pin it is. 14. Let's start with pin 14. Okay. Yeah, don't need that. 5. Save. There we go. Okay. So can we now adjust brightness? Yes, we can. Oh, wait, you can't see it. So now we have WLED control over the LED strip. So let me check the other pins. I don't know the format. 13, 12, 4, and 2. Okay. Let's add a pin. This is also white. I'm not sure how that's going to work with multiple white LED strips in WLED. I don't know. 13, 12, I don't know anymore. 12, 4, and 2. Okay. Pin 4. Pin 2. Yeah, I guess. Pin conflict. Okay. Oh, that's right. Okay. Oh no. Okay. Bam! Made it! 3-hour stream! Oh yeah! Thanks, Drastal! So Andy, you should be happy. We now have a WLED controlled LED strip. Huh? Or 5 LED strips, really. But, so if I now put on an effect, like BPM... Oh! I'm not sure I like this. Okay. Let's do color loop. Okay. 24-hour stream when? I don't know. These are analog LED strips, so there's one LED per strip. But then there's 300 LEDs in reality. Color waves? I guess. Fireworks? What effect would be good? Flow? Holy shit. Okay, gradient doesn't do much. Is there like, I don't know. How's that called again? Ripple? That's cool. Oh, running. That's still a scan. That's it. That should go over all the strips, right? Oh no, make it stop. Yeah, analog LED strips and WLED, I don't know, man. It just isn't my thing. I don't see the... I don't know. It's just, I mean, currently we have 5 LEDs. Because we have 5 outputs. It works. It works beautifully. But... yeah, I don't know. Make them RGB WW. Okay, yeah, sure. I guess. 14, 13, 12. Oh god, and then I need to make this 4, 2. Yeah, I guess we could make this warm white, cold white. Oh, does it have one for 5? Oh, it does. Okay. Yeah, but then it's just going to be one LED. I mean, if I change the colors now, let me put it as solid. I mean, red is now going to light up one LED strip, and then blue is going to light up another, and then green is going to light up another. I don't know what this goes. Oh, this is just going to light them all up. Oh, and then we have the white channel. Yeah, I don't know. Sure, it works. But, oh, the rainbow effect? Okay. Rainbow. Yeah, okay, that's cool. Sure. Yeah, you see that this one is not turning on. That's because internally, WLED doesn't know how to work with RGB+CCT yet. You can configure it, but it won't use more than 4 channels right now. I believe they're still working on that in the background, but yeah. Just keep clicking, that makes a good effect. Anyway, well, I guess this is also a demonstration of how the Ethernet board, or the QuinLED ESP32 ABE, so my Ethernet board, also works on this dimmer because, well, we've been doing that the whole time. Yeah, so this works in ESP Home and in WLED. So, yeah. I'm just going to turn this down a little bit. There we go. Wow! Okay, it's 10 past 12 here. Let me focus myself again. There we go. I think that went awesome. We built a complete board from scratch to end, or from start to finish. We did the stencil, and then we did all the SMD components. And most of them are pretty big. I kept it to 0805. And then there are some smaller ICs, but using the stencil and then using the little hot plate, that worked fine, I think. I think it's pretty easy. And then we did all the through-hole stuff, as in connectors and stuff like that. And then the last step were the 3 DC-DC converters. It's a little bit fiddly to get on there. I have to see if I can find a better method for it. But I'm trying to utilize all the space on the board as best as I can. And this way it's basically floating above other passive components, but not touching. And well, as you can see, that works fine. And yeah. I need to focus myself. There we go. I don't know what more to say. So far, this board's coming along nicely. As I said, I want to make a few more changes. One of the reasons I wanted to build it today is because I wanted to see if I needed to change some stuff in relation to where it was, or fitment, or that it didn't go together easily. But I think it's pretty good already. If you follow the right order, everything slots in its place pretty good. And as I said, I've been doing load tests with it. These are still 1 OZ boards, but they are 4 layer. And some stuff I have routed over all 4 layers. So are they 1 OZ or 2 or 4? I mean, it's kind of a mix. But 4 layers does make it more expensive. But getting all the features on here in a workable fashion, I kind of needed the 4 layers. I get that it makes the board more expensive, but this is set out to be my ultimate analog LED dimmer. And well, if I didn't go 4 layer, I'd have to sacrifice features I wanted to have myself. That's basically how it works. But yeah, it's all working. It's been stable for a while, so that's good. So this project is going to continue, and this is basically also the replacement project for the QuinLED Deca Plus. A lot of what I wanted to bring into the Deca Plus and what I learned from designing that, although it never came out, went into this board. And I think this one is shaping up like I wanted it to. The other one never did. So I'm going to do more testing and stuff like that on it, and I'm hoping to release that later this year. Very likely first DIY, and then I'll work on the pre-assembled version, because this is not something that can be built pre-assembled. You need to use different techniques for that and stuff like that. But I should be able to do that, and then we'll bring that out later. So, hey. Sneak preview time. 5 strips, super warm, natural, day, cold, white. Vary the brightness in different strips, and you get the exact color temp you want. Sure, yeah, with 5 strips. I mean, hello. You can get pretty far with 2 colors, really. Two white colors. I'm really happy with the stream of today. Thanks for it. It guarantees me if I do exactly the same, I don't need my fire extinguisher for the first time soldering. Well, I have a fire extinguisher can right over there. It's right out of the shot. But yeah. Sneak previews, huh? What should I share? Let me think about that. Yeah, that what Andy's saying. If you like this stream, either watching now or re-watching it later, please hit that like button. It promotes it to more people. And although I guess these kind of soldering streams are kind of niche, or there's a small audience who likes to watch them, I like to watch them from other people, so that's why I do them sometimes. But yeah. Okay. Shall we look at something together that I haven't even looked at myself yet? Oh, power supply is warm. Sure, we can do that. This is a testing prototype, and I have no idea yet if I'm going to bring this out. I haven't even built the board yet, so hold on. I mean, PCB box, and it's still in the original packaging with this slip in there. I haven't even unpacked this yet. I haven't looked at this yet. So now there's 2 boards in here, but we're only going to look at one. Yeah. Okay. Now this is a board you already know, but there is one irritation with the current Dig Quad. And that is the screw terminals. So I've been testing a new version. Oh wait, you can't see anything. There we go. And let me get something out of this drawer here. For testing, I've been working on making a new version. Which, if I did it correctly, will fit these. And this is all custom footprints and stuff like that. Okay, so far it seems to fit. Can I still get my fuses on there? Well, not new, updated version, or slightly changed, or prototype, or whatever. I make lots of these. I generally don't show them to the public though. To test out what works best, and you know. So can I still get my fuses in there? Because I changed the fuse footprint too. That works. That works too. And they're not touching. Okay, so I built this because the current screw terminals, although they're very highly rated, they're kind of sucky to work with, and I realized that. So, for instance, the connectors I have on this board, you're like, hey, why wouldn't you use the same ones as we just looked at all this time for the analog board? That's because the analog board is going to run 12 to 24 volts. So the amount of amperage one of these pins needs to handle is much lower than it is on a digital board using 5 volts. So that's why we can't use those pluggable screw terminals in these boards, because I need the terminals to do 10 amps or more sometimes. But these are nice and beefy, and you can use ring connectors like I have, for instance, screwed in my power supply. So let me show you. I think I did this one correctly. So they're basically the same type of terminal you have in this power supply, and you can use one of these fork connectors to really make a good connection, basically. And so that will also fit in here now. So then you could, if you have the crimping hardware, of course, make a very good connection from your power supply. Uh-oh. Well, that's one of the downsides. I don't have a proper screwdriver here. Come on. Really? Okay. Okay. So then you can use a bigger screwdriver. Yeah, so you can make a very sturdy crimped on cable connection. And yeah, but I have no idea yet if this is going to handle the power, how warm this is going to get, if this is going to work out in regards to spacing, if this will survive my personal safety testing. I don't think the height will be too big of an issue, but they are much higher. And yeah, but it seems my custom footprint is working. That's good. And the spacing also seems to work, because the fuses still fit in there. And I might introduce this as a change in the future, because these terminals... Yeah. These terminals can take either stranded or just normal crimped, or with one of those spade connectors as I just showed, and that should all work fine. But yeah, I think this all works out in regards to spacing, so that's good. Yeah, well, that's the secret of the day. I can't... I'm gonna run out of secrets at some point. This box came in today, so at some point I will no longer have any secrets for you guys. But that's, I guess, what you get for sticking around on the live stream for the last 3 hours. I do appreciate you all being here. I mean, that's why I do these things, so hey. So, 23 past 12, let's give it 7 minutes. You guys have any questions left? These are rated for 20 amps per pin according to the UL rating. Oh, wait, it's probably on here. Yeah, so 300 volt, 30 amps it says, but that is probably European rating. The UL rating, I believe, is 20 amps. But they can take 12 to 22 gauge, so that's fine. And they are 9.5 millimeter pitch. Yeah, so that should be enough to handle the 30 amps continuous for the board, in theory. Because before I had 3 pins, and now I have 2 pins. So there is also the heat from the pin connection to the board and the copper planes to think of. which is now 2 pins instead of 3 pins. So it might actually heat up more than before. Of course, these pins are bigger, but yeah, we will have to see. And I'm already thinking of a change here, that I probably want to make the islands for the solder slightly bigger. I use custom footprints on most of my stuff, because I changed the fuse footprint on here too, but I knew that wouldn't work. Oh, I've also added 2 PTCs to the board, and I've done some stuff differently here, but that's all prototyping, testing. Yeah. You have to keep going. Can't stand still, because then nothing happens. So, few minutes question time. Shoot! Can you use analog LED strips for video, and is it good white? Is it safe to drive all LED strips at full power? Or can you program the ESP to shut or dim if the temp sensor is too high? So, all LED strips in my studio are analog LED strips. They're running at 120,000 hertz, so that's why I can do, well, okay, except the wall art over there. That's why I can do all kinds of fading and stuff like that, and you will never see any PWM because they're running at such high frequency. These are running on 2 Deca boards, and I have 1 analog board, or a quad board also. So yes, if you want video lighting, you should use analog LEDs, because then you are assured of the frequency they will run. And what was the other questions? Yes, if you want good white, you have to use analog LEDs. Everything here I'm lit by only LED strips, and the white LED strips are from my premium line. You can check it out on QuinLED-An-Info, and then go to the analog section, and then I have the warm white and the recommended strips. And these are all CRI 95, giving me a very clear and good image, basically. And can you program the ESP to shut down? So you can, in ESP Home, which I'm using for everything, you can set min and max values, so you can limit a channel if you wanted to. And I guess you could program ESP Home or Home Assistant to shut down or turn down the channels if the temperature sensor reaches the preset value. Yeah, that would be possible, yes. Thanks for the nice stream. Maybe stepping up to SMD World myself. The small gourmet device is next to buy. Yeah, if you're gonna, I'll put it in my recommended equipment list. I haven't done that yet, but that little hot plate I have, it's excellent. Highly recommended. I definitely recommend it above a hot air station. Now, if you want to rework some stuff, a hot air station can still be useful. But yeah. What temperature should I consider alarm level for the quad board and HA? Well, we've talked about this before, but it really depends on what it's running and what it's encased in, and if there's a bit of airflow or not, and stuff like that. The board has no problem being 50, 60 degrees, for instance. If it gets hotter than that, but it depends on what the temperature sensor is reading and how hot the board really is. Yeah, I'd say 50, 60 degrees, then you're in the danger zone, I guess. Yeah. Any ideas for the price target for the DIY An-Penta? No. Well, basically I don't charge for the board, so I'd make the board design available on PCBWay and probably dirty PCBs. But as I said, it's a 4-layer board, so I think the boards themselves are easily going to cost you $40 or something like that without shipping. And then the components aren't the cheapest ones, because you need to get the gate drivers and stuff like that, and those are, I think, 50, 60 cents a piece. It's not going to be a cheap board. The quad and the Deca were much more DIY friendly, and also built to either be very small size, like the quad and Deca both are, and also hit a cheapest price target. This is built to be good. So consider it premium, I guess. And especially if you want the Ethernet board and stuff like that, you'll have to buy that from me. You can run it with a normal D1 Mini 32 on there too. That will be compatible. That's no problem. But if you, yeah, I advise my boards, of course. But I have no idea for a price target either for DIY or for pre-assembled. I don't know. I think the entrance cost for DIY might be a bit high if you want to build one board. But if we want to build 5 or 10, the price will be a lot better and probably more in line with what I can do for pre-assembled, basically. But yeah, I don't know. I haven't worked that out yet. No clue. I like the building together stuff, and any together building stuff for that matter. Do you plan to do more build it together live streams? We do build it together live streams all the time. Sometimes it's an LED project or retrofitting something or something like that. But yeah, we do lots of those. Can you put a link for the small grommet device? Yeah, I think it's still in my buffer. Let me check. Nope, it's not. Is it in this buffer? Can't show history. Okay. My screen is blocking myself. I will generate a new link, but my whole wire construction here is, yeah, causing issues. One moment. And there we go. I will also add it to my recommended equipment list. How are the chia seeds going? They're going excellent. I'm farming and I'm currently replotting to the portable plots. I'm doing that at a rate of about 120 to 140 plots a day. So that's going fine. It'll be 2 or 3 weeks and then that's done. And then it's back to plotting. I'm also farming the plots with some alternative cryptos to chia, because you can use the same plots you made for chia. And yeah, that's going fine. Chia price is down. But then again, all crypto price is down. And chia didn't fall as much as the other cryptos. So actually, price-wise, it's doing pretty good. So, yeah. Dave Menkor said, whoa, that's great. The CRY values are great. Thanks, Quindo. Great work. Yeah. So, this board is certainly suitable if you want to make studio lighting or photography lighting or something like that. This board would be excellent for that because you can run the CRI 95 LED strips. You can run a few of the high power LED strips on one board. And yeah, that should all work out. That's perfectly what the design goal is for, basically. Oh, we're 2 minutes over already. So I'm calling it. Thank you guys so much for watching. I hope you, well, you guys telling me you enjoyed it. But give me a like and maybe subscribe to the channel if you're new here. And otherwise, I hope to see you back in a next video live stream on the Discord server or wherever else. And if you feel so inclined, using some of my links is much appreciated. So, thank you very much. Thank you for my moderators for sticking around for this long. And I'll catch you guys the next time. Bye-bye.